June's never going to leave. Okay, so how many segments are we actually dealing with? Two? From 1, 0, 1. Where's this one going? 2, 3, 1. And then where's it going? 2, 5, 2. I'm not trying to make this into scale at all, but there's two paths here, C1 and C2. So what are you going to have to do? You're going to have to parameterize C1 and C2. What's C1 going to parameterize to? What is X going to be equal to? T plus 1? How about Y is equal to T? And how about Z is equal to... Oh, no, I'm looking at the wrong one. What am I doing here? T plus 1? And what's... sorry, what?
Just use T.
You just want to use T? Okay, that's fine. We can use T. Y is equal to what?
Actually, just 3y cannot be
3t minus 3? You want to do 3t minus 3? Which one? Okay, we have now struck upon one of the primary difficulties. How many different ways can you parameterize a given curve? An infinite number of ways, correct? Theoretically, if we do our math correctly, doesn't matter which one we choose? No, we should end up with the same final answer no matter what the parameterization we start, no matter what parameterization we start with. So let's just pick an x of t to start with. What do you want x to be in terms of t? Someone start us off. You want it to be t plus 1. Okay, so if x is t plus 1, what is y going to be if x is t plus 1? 3t? Sounds good. And what's z going to be? Z is just going to be 1. It stays the same, if that's true right there. Nice. Okay, so now can we fill in the blanks on this thing? So we're going from time equals 0 to time equals 1 of t plus 1 times, oh, sorry, excuse me, plus 3t times what? Times 1, right? And what's dx going to be? dt, right? And then what are we adding to this thing? 2 times t plus 1, and it's going to be what, 3 dt? Is that correct? Right? Plus t plus 1 times 3, I got to write that fully. T plus 1 times 3t times 1 times what? Times what? What is d? If z is 1, what's d? If 0 dt. So one of these goes away nicely. Yay, that goes away. That's the 0. Does anybody have what this first one integrates to? June has a vote for 12. Who agrees with 12? Nice. Nice. Okay, you're all agreed. So what is y going to be? 3 plus... I like 3 plus 2t. That's cool. You absolutely can do that. Because now you're going from 0 to 1, right? You like going from 0 to 1? And what's z going to be? T plus? Just t plus 1. So what's our integral going to evaluate? It's going to be from time equals 0 to time equals 1 of 2 plus, it's yz, right? 3 plus 2t times t times, it's dx on this one? Yeah, dx. So it's just going to be 0 dt. Hey, that's nice. Plus what? What is this value? It's 2x. So what is x? 2, and then it's 2x dy, which is what? 2 dt. Plus, what's the last one? xyz dz. So it's going to be 2x y z t plus what? It's t plus 1. dz is just going to be dt, 1 dt, yeah, 1 dt, exactly. Does anybody have an evaluation for this one right here? What does that evaluate? Anybody have it? Okay, so the parameterization works. So then this has got to be, that's x, and that's y, and that's z. And then it's dx right here. So that looks like it's 0. Are we good? Hold on, Leo, what do you got? What do you see? Do you see an issue?
That's 55 over 2 there. It's 50 over 3 on the bottom.
Yeah.
This is a 3. I think she just wrote it quickly. Okay, it's 3. Okay, we almost have it. Okay, let's just try to figure this out. What's this right here? What is... So you just did... Yeah, where's that 4 come from? We're evaluating... Oh, 2x, so it is 4. Okay. Oh, and then it's supposed to be dy? So this right here is 2x, and this is supposed to be dy right here. Well, that's right. Good. And x is 2. That's 4. So this checks out. Seems like it. And then you did, let's check here, x, y, z. So 2 is x, 2t plus 1 is y, and z is t. And then it's supposed to be dz. So it looks like you set it up correctly. So now it might just be a matter of